Because if we need more time for this to kind of sink in, we have an extra day. Our check-in quiz is on Wednesday. So hopefully we're just going to do 2 pages. We're just going to do page 19 and 20. And then Monday, we'll do page 21 and 22. And then Tuesday, I'll create a review worksheet for us. And then Wednesday will be our check-in quiz. Okay. So notice that everything that we've done so far with our normal distribution curve is that we've been lining up nicely with the bars, right? If it's 1 standard deviation away or 2 standard deviation away. But then what happens if we're looking for a probability that falls, that doesn't fall exactly 1 standard deviation away? What if it's somewhere in between? Then we need to have some help, right? Because right now this is only very limited, very rigid in terms of what we can find. So let me go through some of these notes here. A standard normal distribution is formed when using mean of 0 and standard deviation of 1. Okay. So we're going to use this when x value does not fall on a standard deviation. The empirical rule still applies to a standard normal distribution. Okay. So to change an x value from a normal distribution with a mean x bar and a standard deviation sigma, we use a z-score formula. So z-score formula allows us to get this to be a little bit easier to work with. Okay, now. Okay, so right now we are, I think it's kind of hard to see this. So I meant for this to be a little bit, yeah, this is a little bit displaced here. So if you guys can understand that this is z equals 0 here. Okay, z equals 1, z equals 2. It's just a little bit off center here, but this is z equals -1. Okay, and z equals -3. Okay, so z-score is the number of standard deviation the x value lies away from the mean. Okay, so we're forcing a mean of 0 and standard deviation of 1 to allow for us to work with problems that are a little bit where the numbers don't line up as nicely as we would like. Okay, example 1, for standard normal distribution, find the following probability of a normal randomly selected x value from the distribution. So it says probability of z value less than or equal to -1. So if we're using z's here, then we can simply go from 0 to -3 and then 0 to 3 on the right side. Okay, so less than -1. Okay, so from the table yesterday, we know that, let me fill those numbers in again. We know this is 34, 13.5, 2.35, and then 0.15. Okay, same thing on the other side. So if we want the probability of a z less than or equal to -1, then 5 plus 2.35 plus 13.5. Okay, so we're just getting used to these z values here. Z greater than or equal to 1. Then everything to the right. Everything to the right of 1. So 13.5 plus 2.35 plus 0.15. Same idea, right? Same thing, 16%. Okay, between -2 and 3. Between -2 and 3. Add up all those numbers. Or we can do 100% minus 2.5. Let's see here. Oh, between -2. Oh, between -2 and 3. Okay, so we add up all those numbers there. 97.35. -2. Here. Okay, so consider a normal distribution with a mean of 72 and a standard deviation of 3. And if we try to follow through with 72 and standard deviation of 3, if we subtract 3 from both sides and add 3 from both sides, we're not able to land on 65. So if we go through, actually, right now we're just going to convert and find the z-score. Okay, so the formula that we're going to use is up here. Z is x minus x bar over sigma. So x bar is my mean, sigma is the standard deviation, and x is the value that we are considering. Okay, so we're going to apply that for each of these problems here. Okay, so x, that's 65. Mean, that's x bar. Standard deviation. So 65 minus the mean divided by sigma. Okay, 65 minus 72, use our calculator, divided by 3. Okay, -2.33. We'll just round the 2 decimal places. Okay, we'll talk about what this means. We're going to be able to use the table that you can find at the very beginning of this packet. Okay. But right now, let's just go ahead and find the z-score, and we'll talk about what it means when we go down below. Okay, x equals 81. Find the z-score. Okay, x minus x bar. Okay, 9 divided by 3 is just 3. Okay, we're just going to always show 2 decimal places here. Okay, same formula again, x minus x bar over sigma. Okay, so z-score enables to find any probability with a table of values. The probability given on the z-score table is probably that is less than the z-score. So we just always have to remember that whatever we get is less than. So if we want greater than, we have to make some adjustments. Okay. So be careful. We're not always looking for less than. Okay. We'll start out with some easier ones here. We'll start with less than, and we'll talk about greater than. We'll talk about between. The between is going to be the messiest. Okay. So example 3, consider normal distribution with a mean of 72. Let's go ahead and mark that down. We know, same as before. Standard deviation, that's sigma. Okay, so 65, right? We found the z-score from above, which is negative 2.33. And just to kind of show that this, we're not able to quite rely on just the percentages that we've done in the past, right? Just to kind of show you that we're kind of in between slots here. Okay, let's build this a little bit here. So 72 is our mean. Add 3 to the right and subtract 3 to the left. Okay, if I subtract 3, I get 69, 66, and 63. Now, if I want the probability of less than 65, notice that 65 doesn't land exactly on the standard deviation, right? It's between 63 and 65, but ultimately we're looking for something that is in this range. Right, we know it's going to be somewhere between 0.15 and 2.35, but we don't know exactly where, right? It's kind of like a guessing game. So here, we're able to find that exact value using z-score. Okay. So we're going to use this negative 2.33 to help us out. Okay. So when you see less than, it's easy. You're just going to take the probability from the table. Okay, so how do we use the table? Okay, so if you guys turn to the very front of your packet, pages 2 and 3, again, the z value that we found from part A, it's the same number here, is negative 2.33. Okay, so I'll put that here. Z equals negative 2.33. Okay. So on page 2, it's going to be all the values that have negative z values. Okay, and then page 3, we're going to have all the positive z values. Okay, so right now we're in the negative z values, so negative 2. Find that negative 2.3 first. We're not going to be able to find the hundredth, just the tenth. So negative 2.3. Find that negative 2.3 on that right column that's highlighted. Do you find it? Negative 2.3. So now we're going to find that negative 2.33. So 0.01, 0.02, 0.03. So we find that value, which is here. So very, very small percentage, right? Just like what we were expecting, right? Near the edge of the curve there, but we don't know the exact value. Now, if it's less than, we can just put that number down and there's nothing more that needs to be done. If you see less than, is going to be the easiest. Whatever number you see there is your decimal or is your percentage. Okay, so we can say the probability that x is less than or equal to 65 is really, really small, 0.0099. Okay, any questions so far? Let me zoom in a little bit here. Easier to read, hopefully. Okay, probability of x. Okay, everybody okay so far? That makes sense. Okay. So when you see greater than, Okay, bit of a red flag here. We're still going to find z-score. We're still going to be able to go through the chart, but we have to make some adjustment because the z-score on the table is only giving us less than. If we want to do greater than, we got to make some adjustments. So if you see greater than or equal to, it's always going to be 1 minus the probability. So for instance, if it was greater than 65, I can't rely on that 0.0099. I got to do 1 minus 0.0099. So if you see greater than, you just have to go through the same process, but it's one additional step. I got to subtract my probability from 1 because what I get is not going to be less than. Well, what I get is always going to be less than. If I want greater than, I got to involve the other side of that dividing line. Okay, same process though. Initially, 81, we already got that information from above. So Z is 3. Again, as you can see, it's not going to line up nicely. $72, $75, $78. $81. Okay, it looks like it is lining nicely. Okay, either way though, let's just go ahead and use the z-score, use the chart as well. So z is equal to 3. So let's go to 3 on our table. This is on the positive side. So 3.0. is 0.9987. However, we see greater than or equal to. So we know that 0.9987 is the data for less than. If I want to do greater than, I got to take that number and subtract it from 1. Okay, and then the final variation is if I'm trying to find the probability between two values, then I have to subtract the z-scores from each other, or subtract the probability from each other. Okay, so if you see x between two numbers, then you're going to subtract two probabilities from the table. Okay, so we have 76 and 81 available to us. So 76 is 1.33 and 81 is 3.0. Okay, so 3.0 we already have. 3.0 is going to be 0.9987. Right, let's find the one for 76. We already have that from above. We found the z-score is 1.33. So make sure you don't subtract that 1.33. We got to find it from our table first. So let's go to our table. This is on the page 3 because it's a positive z-value. So 1.33. So we first find 1.3. Okay? And once you get that 1.3, then you're looking for that last 0.3. So 0.1, 0.2, 0.3. There we go. Okay, 0.9082. And we'll subtract that. Okay, use your calculator. 0.0905. So again, to recap, we're always going to go through the formula first to get the z value. Once we get the z value, we go to our table, get the decimal. Once you get a decimal, make that decision. Can you keep the decimal? Do I need to subtract from 1? Or do I need to subtract 2 decimals from each other? It's either one of those 3 options. Okay, any questions? All right, we're just going to practice through these concepts on the next page, page 20. And that'll be it for today. Okay, page 20. Okay, does anybody still need this page? Okay, mean is 70. Standard deviation 10. And then we're always going to go through this formula here. Z is equal to x minus x bar divided by sigma. Okay, find the z value first. Okay, as soon as you find your z value, you're going to go to your chart, go to your table. Okay, all we need to do is, I think that first column will get us there. There's no 100th place. We just have to go to negative 0.5. There it is, negative 0.5. Okay. 0.3085. I'm going to do A, B, and C with you, and then I'm going to walk around to see how you guys do with D, E, and F. Can you guys get those values on your own? Okay. Next up, 47. We'll find our z-score. Sorry, yeah, 47 minus 70. Find the decimal. Negative 2.3 is on page 2. So negative 2.3. There we go. 0.0107, but is this going to be the final? Okay, I got to do what? Subtract from 1. Yep. So my probability is always going to be 1 minus what I found. Because whatever you find on the chart is actually showing less than. Use your calculator. Okay. For C, it may take a little bit longer because we got to find z-scores for both and decimals for both, and then also subtract the two decimals. Okay, so part C kind of takes the longest, kind of like two problem in one. Okay, I need to find two z-scores, two decimals, and then subtract the two values. Make sure that you don't just subtract these numbers, right? We're not ready yet. We got to find the decimals first, and then, well, from the table, and then subtract the decimals from the table. Okay, negative 1.6. 0.0548. $1.3, that's over on the positive side. 0.9. Okay, subtract the smaller from the larger, so we'll do 0.9032 minus 0.0548. Okay, does that make sense to everyone? Okay, so spend the next few minutes going through D, E, and F. I want to kind of walk around and make sure that you can do these problems on your own, because I want to help you out if you're stuck with some of these steps. Okay, but we're following the same thing as above, right? For less than, you just get that decimal, you're done. Greater than, once you find that decimal, subtract from 1. If it's between, then you got to find two z-scores, two decimals, and then for the table and subtract those two from the table. Again, you're pulling the table values from page 2 and page 3. Page 2 will be your negative probabilities, and then page 3 will be your positive probabilities. Okay. All right. See how well you guys can do here. Okay, we'll walk through number 2 together, but don't want to go to number 2 before I feel like you guys are good with number 1. What did you get for ag? I got 0.1831. Number 2, same idea. If you guys are starting, that's good. We're just kind of merging what we've learned from the past 2 days together. Okay, so continue working on number 2, but I'll go ahead and I'll work alongside you guys. But walking around, looks like you guys are pretty good with D, E, and F. That's good. Okay, build your draw and label your normal distribution just like from yesterday. So mean is 100. You can add 15 or subtract 15 as you move away from the center. Okay, let's talk about at least. What does that mean? At least means probability where x is what? Less than or greater than 121. Careful though, at least means, yeah. I know you see the word least and you feel like you want to go less than, but at least means 121 is the smallest, want everything to the right of 121. Yeah, careful with those wordings there. If you don't see it lining up with your standard deviation values, then you got to go through z-score. And it's z greater than, so after we find our z-score, after we find our decimal, we still got to subtract from 1. Okay, find 1.4 in your tables. Okay, again, it's the wording that trips a lot of students up. What does no more than 79 mean? That means less than, right? That means less than 79. But it does make for an easier process because once you find your decimal, that's it. You don't have to subtract from 1. Okay. Part E is a little bit strange. You have to solve for a different variable, but I'll do part D first. Okay. Negative 0.9.53. You got to find negative 0.5 first, and then move over to 0.3. see. %. Okay, so the closest that we can find, higher than 80%, the closest that we can find off of this is right here, right around 84. So we'll let that be our, here's our formula. So the percent is 0.84. So we're kind of just working our way backwards. And solve for x. A little bit backwards here, but let's just work our way through. Cross multiply here, x minus 100 is equal to 15 times 8.4. Which is 12.6. Add 100 to both sides. So that's our best estimation, right? Around 84% would be yeah, 112.6. All right, let me check pages 19 and 20.